Riset dan Inovasi Nasional, Bapak Dr. Hasnan Abimanyu, Diplom Engineer. Yang terhormat, Kepala Pusat Riset Sistem Produksi Berkelanjutan dan Penilaian Daur Hidup, Badan Riset dan Inovasi Nasional, Bapak Dr. Nugroho Adi Sasongko, PhD, IPU. We would like to express our sincere gratitude to our speaker, Deputy Director of Sustainable Engineering Group, Curtin University, Australia, and co-leader of Research Program 3 of Health CRC, Associate Professor Wahidul Biswas. Thank you for being with us in this webinar today. Dan yang kami hormati, Bapak dan Ibu Periset Badan Riset dan Inovasi Nasional, beserta seluruh staf. Kami ucapkan terima kasih telah bergabung ke dalam webinar Pusat Riset Sistem Produksi Berkelanjutan dan Penilaian Daur Hidup dan ENMA Webinar Series dengan judul Industrial Ecology and Sustainability Assessment. Perkenalkan, saya Yomil Putri Erlambang yang akan memandu acara hari ini hingga pukul 12 nanti. Hadirin yang saya hormati, mengawali acara pagi hari ini, marilah kita dengarkan sambutan dari Kepala OR Energi dan Manufaktur, Badan Riset dan Inovasi Nasional. Kepada Bapak Dr. Hasnan Abimanyu, Diplom Engineer, kami persilahkan.
Terima kasih Mbak Yomil. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera buat kita semua. Pertama-tama kita panjatkan puji syukur kepada Allah Subhanahu wa taala yang telah memberikan nikmat kepada kita sehingga kita bisa berkumpul pada pagi hari ini meskipun secara virtual karena diberikan nikmat sehat oleh Allah Subhanahu wa taala. Yang kedua, saya ucapkan terima kasih kepada Pak Nugroho atas undangan ini untuk menjadi memberikan sambutan. Dan ketiga, saya ucapkan terima kasih and I will thank to Dr. Wahidul Biswas as the speaker today, and thank you very much for your time and for your sharing, knowledge sharing here in this webinar today. Bapak-bapak dan ibu sekalian, ini temanya atau topiknya Industrial Ecology and Sustainability Assessment ini memang sedang booming ya, sedang hangat-hangatnya ya, dilakukan banyak periset di luar negeri dan memang ini menjadi satu isu yang diangkat ya, karena industrial ecology ini bisa membantu dalam rangka kita meringankan beban lingkungan yang ada di sekitar industri tersebut ya. Nah, saya harapkan dari webinar ini kita bisa lanjut mendiskusikan tentang bisa jadi industrial ecology dan sustainability assessment ini menjadi konsep buat industrial park yang akan datang gitu ya, sehingga ketika pemerintah atau katakanlah komunitas industri ya, yang ingin membuka industrial park itu melihat industrial ecology ini juga dulu ya, dan juga bagaimana assessment untuk sustainability-nya dan juga yang lainnya, sehingga basis pembangunan atau pembukaan industrial park itu bisa menjadi sustain dan juga bisa meringankan beban daripada lingkungan di area industrial park tersebut. Nah, mungkin itu saja sambutan dari saya. Semoga webinar ini bisa terus dilakukan, maksudnya dilanjutkan ya, bukan hanya melakukan webinar saja gitu maksud saya, tapi dilanjutkan dengan hal-hal konkret ya, sehingga melahirkan konsep-konsep yang baru yang bisa kita kita berikan kepada pihak-pihak yang berwenang. Mungkin itu saja. Terima kasih sekali lagi dan selamat berwebinar. Semoga sukses. Assalamualaikum warahmatullahi wabarakatuh.
Baik, kami ucapkan terima kasih kepada Dr. Hasnan Abimanyu. Bapak dan Ibu yang saya hormati, acara selanjutnya adalah sambutan dari Kepala Pusat Riset Sistem Produksi Berkelanjutan dan Penilaian Daur Hidup, Badan Riset dan Inovasi Nasional, Dr. Nugroho Adisasongko, PhD IPU. Kepada Bapak Dr. Nugroho Adisasongko, kami persilahkan.
Thank you, Mbak Yumil. Very good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Yang kami hormati, the Honorable, our Chairman of our Research Organization of Energy and Manufacture, Dr. Hasnan Abimanyu. Thank you very much for opening speech this morning to open this webinar. His Excellencies, Professor Wahidul Biswas, thank you very much to give your short lecture today, and then this could be the good initiation to open discussion and cooperation between our organization, Badan Riset dan Inovasi Nasional, National Research and Innovation Agency, and your university, Curtin University. I know that Curtin University is very huge and very well known, very famous in Australia, also in the world. And then you also the vice director of the Department of Sustainable Engineering Group in Curtin University, and this is a good chance for us to start collaboration in the industrial ecology and sustainable assessment research activities both in Australia and in Indonesia. Perkenalkan, hari ini kita menghadirkan Profesor Wahidul Biswas. Beliau adalah Vice Director dari Sustainable Engineering Department di Curtin University, dan beliau cukup terkenal terkait dengan aktivitas-aktivitas sustainability di Australia, terutama terkait dengan natural resource management dan industrial ecology. Dan ini kesempatan yang baik untuk teman-teman. It's a good chance for us, especially for you who want to start to find the postgraduate and doctoral program, also the postdoctoral activities in Australia. Curtin can be good choice under Professor Wahidul Biswas supervision. Profesor Wahidul Biswas sangat tertarik untuk membangun kerjasama dengan Indonesia, khususnya dengan BRIN, terkait dengan industri, terutama industri-industri berbasis natural resource, seperti batu bara, kemudian mineral, dan juga pertanian, agriculture, dan juga riset-riset terakhir beliau terkait dengan low carbon transition dan juga circular economic. Mungkin demikian introduksi dari saya, dan kami juga sudah berdiskusi dengan Profesor Biswas bahwa kedepannya nanti kita akan mengadakan kerjasama riset, terutama terkait dengan energi transisi dan circular economic. Mudah-mudahan di sini banyak teman-teman yang tertarik untuk bergabung untuk melakukan riset bersama, dan tentunya juga membuka kesempatan untuk teman-teman juga mengambil kuliah di Australia, terutama di Western Australia. Mungkin demikian, Profesor Wahidul Biswas. Hope you understand our bahasa Indonesia because you have plenty of Indonesian student there.
I will try. Yes, I will try. Yeah. And yes, a few words I can tell. Yeah.
Yeah, most of your students already become the big boss now in Indonesia.
They are big boss. We feel proud of them, and we are glad to have them. Yeah, and they are doing great job. Yeah.
Thank you. So I hope we can hand in hand to collaborate for any kind of the research activities with us in BRIN, and this can be a good chance to start the cooperation. Thank you very much. Makasih Mbak Yomil.
Baik, Terima kasih Bapak Dr. Nugroho Adi. Bapak dan Ibu, sebelum masuk ke acara utama, mari kita foto bersama terlebih dahulu. Oleh karena itu, kami mohon Bapak dan Ibu untuk on kamera. Ladies and gentlemen, before we start main event, to memorize this webinar, I would like to invite you into photo session. Please turn on your camera. Okay. 3, 2, 1. First slide. Second slide. Last slide. Baiklah, Bapak dan Ibu yang berbahagia, mari kita masuki acara inti yang akan dipandu oleh moderator. Kami mengundang Bapak Hermawan Febriansa, STMT, sebagai moderator. Namun sebelumnya, saya akan membacakan CV dari moderator kita.
Professor Biswas, I also invite Martin to join this webinar. Hope some people from Murdoch and Curtin on also CSIRO come to join.
That's good. Oh, that will be great indeed. Yeah.
Thank you. Bapak Hermawan Febriansah, STMT, adalah peneliti ahli pertama di Pusat Riset Sistem Produksi Berkelanjutan dan Penilaian Daur Hidup Badan Riset dan Inovasi Nasional. Beliau menyelesaikan S1-nya di UGM dengan program studi Teknik Fisika dari tahun 2008 hingga 2012. Kemudian melanjutkan magisternya di UI dengan jurusan Teknik Sistem Energi pada tahun 2020 hingga 2022. Karya tulis ilmiah beliau telah disitasi sebanyak 45 dengan H indeksnya 3 dan I10 indeksnya 2. Pengalaman bekerja dari tahun 2012 hingga 2013, beliau adalah internal audit PT Salim Infomas Pratama Tbk atau Indo Agri. Kemudian 2013 hingga 2014 sebagai Commercial and Transportation Officer PT Salim Infomas Pratama Tbk. Kemudian tahun 2015 hingga 2021 adalah peneliti standarisasi Badan Standarisasi Nasional. Dan 2022 hingga sekarang adalah peneliti kelompok riset Sustainability Assessment, Eco-Design and Industrial Ecology, Pusat Riset Sistem Produksi Berkelanjutan dan Penilaian Daur Hidup, Badan Riset dan Inovasi Nasional. Berikut adalah publikasi yang beliau telah lakukan dari tahun 2013 hingga tahun 2022. Dan berikut adalah pengalaman riset beliau dari tahun 2011 hingga tahun 2022. Bapak dan Ibu, mari kita masuki acara utama. Kepada Bapak Hermawan Febriansah, STMT, kami persilahkan.
Ya, terima kasih Bu Yaumil, terima kasih Pak Hasnan, kemudian Bapak Nugroho yang sudah membuka webinar hari ini yang dengan tema Industrial Ecology and Sustainability Assessment. Thank you for Professor Wahidul Biswas can present in this webinar for Industrial Ecology and Sustainability Assessment. Dan terima kasih Bapak Ibu semua telah hadir di acara webinar hari ini yang diselenggarakan bersama Pusat Riset Sistem Produksi Berkelanjutan dan Penilaian Daur Hidup Badan Riset dan Inovasi Nasional yang bekerjasama dengan Curtin University. Nah, today we will hear the presentation from Professor Biswas about industrial ecology and sustainability assessment. The engineering context of sustainability involves the design and management of sustainable technology, research in the environmental and social impact, and a good understanding of the limitation of carrying capacity and management of resources using a cradle-to-cradle life cycle approach to assess eco-efficiency. Industrial ecology is a marketplace of concepts, methodologies, tools, and practice that can develop and implement stepwise improvement and innovation in the resource efficiency of current and likely future production consumption system asset sustainability. This presentation cover three main tools in industrial ecologies. There are life cycle thinking, material flow, and industrial symbiosis. Before I give the time to Professor Biswa, I will introduce you about Professor Biswas. Sorry, I will share the screen for Professor Biswas. Yeah, Professor Biswas is a Deputy Director of Sustainable Engineering Group, Carleton University, and a co-leader of Research Program 3 of ILLT CRC. He was trained as a mechanical engineer, researching the performance of diesel engine using biogas fuel. Then he has gradually diversified his research to engineering for sustainable development and interdisciplinary field. He has a master in environmental technology from Imperial College London and a PhD in sustainable futures from the University of Technology, Sydney. He teaches and coordinates core undergraduate engineering unit, engineering for sustainable development, and at Carleton University. He has so far carried out extensive life cycle assessment and sustainability-related research on Australian agriculture, alternative fuels, building and construction, manufacturing, mining, and water sector from the Department of Climate Change and the Grants Research and Development Commission and Department of Agriculture and Food, Western Australia. And I think professors have been many experience in research about sustainability. When we will see in the scholar in Google Scholar, we can see that Professor Biswas has been many research in sustainability assessment, life cycle assessment, and life cycle sustainability assessment. I think this time we have very experienced, interesting experience about sustainability from Professor Biswas. I think now the time is yours, Professor Biswas.
Okay.
Okay. Thank you, Prof.
Thank you very much.
The time is from today until maybe in 11 o'clock.
Okay.
Okay.
Thank you very much, Dr. Harmawan and Dr. Hajnan and Dr. Nugroho, and thanks for giving me this wonderful opportunity to share my experience with all of you. Assalamualaikum warahmatullahi wabarakatuh. And thank you. Terima kasih. And I'm going to share my screen with you. Hopefully, let me check. So, are you able to? So, that's good.
Yes.
Thank you very much indeed.
Okay. Yeah.
Okay. Now, okay. So, ladies and gentlemen, I'm going to first discuss the concept of industrial ecology. Then I'm going to discuss how we can do sustainability assessment, and there are some case studies on industrial symbiosis, and I will discuss what is MIPS, material intensity per unit of service, and I will give you an example from one of my former PhD students' work on palm oil sustainability assessment, and this will help you to understand in the concept of industrial ecology and the type of tools that are essential for conducting a sustainability assessment for any product. So first I start this definition of sustainable development. Sustainability is something we need to see our grandchildren, grandchildren smiling. And when we can see them is smiling when they have got enough resources. So we need to do something in order to leave adequate resources for our future generation. And that is known as the concepts are contextual, like democracy and justice for our future generation. There are plenty of ways that we can achieve this goal and or sustainability. And each of these ways are known as sustainable development pathways. It can happen through energy efficiency, renewable energy technologies, remanufacturing, reducing, recovering, reusing. All these strategies are pathways to conserve resources for our future generations so that they can live the same lifestyle that we are living at the moment. So that is the difference between sustainability and sustainable development. So I like this definition. The reason I like this definition because this is engineering context of sustainability involves the design and management of sustainable technology. The sustainable technology is the technology that offers economic benefit, reduce environmental impact, and enhance social equity. There are two types of social equity. Intergenerational equity means leaving plenty of resources for our grandchildren so they can live the same lifestyle like we are enjoying at the moment, and enhances intragenerational equity, reducing the gap between rich and poor, so equity between the people in the same generation. Research into environmental and social impacts and limitation and living within global limitation. We have got 1 Earth equivalent amount of resources, but at the moment we are consuming more than 1.6 Earth equivalent amount of resources. So we need to design technologies in a way that we can live within our means. We need to design technologies that is resource efficient, that can help improve environmental performance, social performance, and economic performance, and management of resources from cradle to cradle. So we need to design product in a way that after the end of life, we can give a new life. That I discuss with my students. What doctors cannot do, engineers can do. So engineers can turn end-of-life product to a new product, usable product. And we need to think in our design stage that whether it can be recycled, whether it can be disassembled, whether it can be remanufactured, recovered, so that we are able to avoid the use of virgin material and keep the same material used over and over, thereby reducing the flow of throughput from nature. So design operational processes, structure, mechanical, and we need to take into account all this as operational stage. We need to make sure that our less consumables, less chemicals, and it is less energy intensive. After that, after use stage, we make sure that we prevent this end of life product going to landfill by recycling, reusing, remanufacturing, recovering, redesigning, etc. So, as I mentioned to you, that we need to avoid the end of life product going to landfill, so that landfill is considered as sink. And if we are able to reduce the size of sink, we can automatically reduce the size of source. And so that means that we avoid mining, processing, manufacturing, all these upstream activities, and we can achieve a circular economy. And industrial ecology is a subject that addresses these two issues. It can help reduces two S's, one S for sink, one S for source, by converting waste to resources, by minimizing resources, and by minimizing waste, energy, material consumption. In one word, reducing the pressure on Mother Nature and leave a better world for our future generation. So this is a marketplace for industrial symbiosis that I will be discussing with you. Industrial symbiosis means the exchange of product and byproduct between industries. Regional synergies means lots of exchanges can be happening between industries in an industrial area. So industries can exchange energy, waste energy, wastewater with each other and become more resource efficient. Life cycle assessment is an environmental management tool or a diagnostic tool that can help engineers or policymakers or scientists to come up with the better option. This is a decision-making tool that can help achieve a sustainable solution. Eco-efficiency, doing more with less. This is an objective, and we can do it by applying 5 cleaner production strategies: input substitution, product modification, on-site recycling, good housekeeping, and technological modification. Biomimicry, we need to be efficient like nature. Nature is efficient, live within constraints. And we need to design any technology that mimic nature. By mimicking nature, fuel consumption, water consumption will be reduced, waste generation and emission will significantly reduced. And eco-industrial park means that we need to come up with industries in a way that they are capable of exchanging product and byproduct with each other, avoiding the use of virgin materials, avoiding the importation of material from other countries, and self-dependent, self-sustaining, reducing the size of landfill as the waste are converted to resources. One industry's waste is converted to resources for other industry. So industrial ecology encompasses this broad range of tools. So if you look at here, there is a cure. Prevention is better than cure. Means that instead of installing a pollution control technology, we can do the internal improvement. If we're using clean fuel, clean processes, clean energy, we are automatically reducing the pollution. We don't need to install any pollution control technologies. So prevention is better than cure. So if you're doing the internal improvement, and if meaning that you're already reducing the emission, you are saving money. So it gives you 2 benefits, economic and environmental benefits. So if you are doing curing, it is not a good strategy because you're not saving money, but just controlling the pollutants. You're not improving the environmental performance of your industry. And environment and economy go hand in hand, meaning that if you are using these preventative measures, you're automatically controlling the emissions. And this is known as cleaner production strategies. Now, cleaner production strategies, it can be regulatory driven, but sometimes that there are some economic incentives. People get advantage of the reduction of emission and save carbon tax, and they can save fuel, save energy by using efficient technologies, and that's reducing environmental tax by using efficient technologies. What does it mean? Meaning that that there is a win-win situation, and this is a good business case. Now, eco-efficiency, doing more with less. If you use cleaner production strategies, you can help achieve eco-efficiency. Eco-efficiency help achieve 2 objectives: economic benefit and environmental benefits. Cleaner production strategies, as I mentioned to you, input substitution, product modification, recycling, on-site recycling, technological modification can help achieve this eco-efficiency. And eco-efficiency is one of the key objectives of industrial ecology. And industrial ecology, as I mentioned to you, that it reduces 2 S's, sink and source, avoiding the pressure on Mother Nature, leave more adequate resources for our grandchildren. And then comes design for the environment. This is very important part, without which we cannot do recycling, remanufacturing, recovering, reusing, etc. Because we make sure that after the end of life, it can be disassembled, it can be remanufactured, repaired, so that we can give new life to an end-of-life product rather than sending it to landfill. That's why life cycle focus is very important. Now, industrial focus on product design. There are marriage is happening between industrial and ecology. Industrial system, we are producing product, we need material, energy, water, etc. And when we produce things, nothing is 100% efficient in this world, waste is generated. So the case of industrial ecology, there is a liquid interface between industry and the surrounding environment, and it is not a solid interface, meaning that when you're considering industrial ecology, we need to take into account how the industry's pollutions, waste are affecting the surrounding environment, community, etc. And we are reducing the external cost, because the pollution created by the industry will cause a health effect. It will increase their health cost. That is known as external cost. But if we're mitigating emission, if we're reducing energy consumption, waste generation, we are avoiding this external cost. In order to make it happen, we need to put extra money, and that is known as internalization of external cost. So that is the philosophy of industrial ecology. Also, industrial ecology is something that we need to design any industrial system that follows a natural system. In the case of natural system, you will find that if you go to Amazon forest, which is not affected by human activities, leaves, twigs, the dead materials, they're converted to inorganic material by microorganism, and that inorganic materials are taken up by plants. So their nutrient cycle is going on, nitrogen cycle, carbon cycle, phosphorus cycles, so we need to design our industrial ecosystem in a way that the machine that we use that can easily be remanufactured, and the components can be recovered, and so that nothing is wasted, and everything that was that are used somehow be recycled, remanufactured, and it can exactly follow the natural ecosystem. So that what is the main thing? To reduce source, reduce the amount of land that is required for mining or extracting, quarrying materials, or the amount of land that is used for disposing waste. So there are two S's can be avoided while enhancing resource productivity, efficiency, by developing an industrial ecosystem that follows the natural ecosystem. So industrial symbiosis, this is a significant part of industrial ecology. The reason is this, that it deals with the interrelationship between industries. And what is the interrelationship? One industry's waste, one industry's wastewater, waste heat, or solid waste can potentially be converted to resources by the neighboring industries. And it requires a collaborative approach. And the collaboration, coordination, these are two key words in enabling this industrial symbiotic process, so that these industries, they can be mutually benefit from each other. So there are a number of synergies. Inorganic byproduct synergies means that industries like mining industries, processing industries, refinery industries, chemical industries, they produce huge amount of inorganic byproduct like gypsum, lime clean dust, cement clean dust. All these are inorganic byproducts. They're useful byproducts, so that they can be used as soil amendment purposes. They can be used as in the process application. So and this inorganic byproduct can help make a symbiotic relationship between two neighboring industries. Utility wastewater can be treated. One industry's wastewater can be treated, and that can be used by another industries. Waste can be recovered by heat exchanger, and depending on the temperature, that recovered heat can either be used for generating electricity, or this can be used for process applications. So, and supply chain synergies means stakeholders in the supply chain, they can benefit from each other. Like photocopy machine, it can be used by two industries, and that can help make a connection between two industries. Or is a utility company, that utility can serve both industries. So instead of having an industry to have their own power plant, one power plant can be shared by two industries, and this is how it can help dematerialize economy, dematerialize energy, and reduces energy consumption. And gaseous synergy, that is another one that one of my doctoral students couple of years completed. That in the case of that is fertilizer industry, they produce, now in the case of refinery, they produce huge amount of sulfur dioxide, nitrogen dioxide, that can potentially be converted to feedstock for producing fertilizer. So fertilizer company and the refinery, they can make a symbiotic relationship by converting each other's waste to resources. So there are some examples for byproduct synergies. Byproduct means solid waste, like that is cement. That is in cement production, byproduct is lime kiln dust that can be used in pig iron plant. Also, it can be used in dye waste. It can be used in pigment plant. So this they can one industry's byproduct can be used as another industry's resources. And recently, we have proved that we got a funding from Coburn Cement, and this lime kiln dust can act as a very good road construction material, and it increased the performance of road. So you can use lime kiln dust as a good pavement material. Also, there is another example is CSBP is a fertilizer company. They produce gypsum, and that gypsum can help the improve the or amend the soil of the residue area. Residue area means alumina refinery. They produce bauxite residue. When they convert bauxite to alumina, bauxite residues produce bauxite is residues very alkaline. So in order to neutralize it, you need gypsum. And this gypsum is coming from the neighboring fertilizer industry. So these are some typical inorganic byproduct produced by the industries. I think that is Australia is advancing quite good, like iron or steel making slag. It can be a good construction material as a replacement for cement. Fly ash, bottom ash. Fly ash is a very good cementitious material that's produced in coal power plant. And sand, foundry sand, can be used as a in concrete, and I think lime kiln dust we have proved recently, and that it can be used as a in asphalt filler, asphalt, which is the top layer of pavement. And there are other organic byproducts. So that organic byproducts, most of the organic byproducts, they have got cementitious property. And cement is one of the most energy intensive and carbon intensive materials. So that if we're able to reduce certain portion of cement with this industrial byproduct, we can significantly reduce the carbon footprint, energy footprint, and while maintaining the structural properties of this materials. And I have already completed good number of projects in this area, and we have proved that recycled aggregate, recycled glass, and all this industrial byproduct can have potential to replace virgin materials and increase resource efficiency. So there are some examples. We have discussed byproduct synergies, and there are utility synergy. Utility synergy means dealing with wastewater and waste energy. And as you see that BP refinery produce, I think, the effluent that is generated by CSBP, and that effluent that is generated by CSBP is a fertilizer company. And naturally, the effluent that is coming from CSBP is enriched with nutrient, and that effluent is going to the wetland of BP refinery. BP refinery is the neighboring industry of CSBP. So the use of effluent in the wetland is increasing the vegetation coverage. This has got environmental benefit because it is sequestering carbon dioxide. At the same time, it is treating the water or effluent. Also, in the Kwinana industrial area, they have got a cogeneration plant. Means that there are lots of process heat produced, waste heat produced, and process application, and you need to have heat exchanger to extract this heat. When you extract this heat, temperature is very high, and they're utilizing this temperature to generate electricity. And the electricity generated by this cogeneration plant is used by the industries, contributing waste heat to this cogeneration plant. So this is Kwinana waste water reclamation plant. So in Western Australia, we have got Woodman Point water treatment plant. This Woodman Point water treatment plant, this treats the wastewater before it is disposed to ocean. So instead of disposing to ocean, what happens that it goes to Kwinana industrial area. Sorry, I forgot to mention to you that Kwinana is an industrial area which is 20 kilometers away from Curtin University, where some good things are going on. Good things means all these symbiotic processes are happening between industries, and we are one of the most iconic place in the world, and people coming here, they visit Kwinana because it is a perfect example for industrial symbiosis. Now, in the Woodman Point, now what is happening that instead of sending this treated water to ocean, this water is transferred to Kwinana wastewater reclamation plant. It has got reverse osmosis system. The treated water is further treated so that it can be used for boiler and process applications. So it means that water to address the water scarcity, and to reuse the water, and to reduce the pressure on water that is coming from this energy intensive or costly desalination plant. So this is an example I want to give you, that this is Kwinana, as I mentioned to you, it is 20 kilometers away from our Curtin University. In 1990, there were 27 interactions between 13 industries. Each interaction means each symbiotic relationship. Each symbiotic relationship means one industry's wastewater or waste energy or solid waste is used as a useful resource by the neighboring industry. So there were 13 interactions between 27 industries. Now, so number of interactions or number of synergy or number of symbiotic relationship is 2 per industry. But after 10 years, it increased to 4 symbiotic relationship or 4 synergies per industry, meaning that environmental improvement happens significantly, more conversion of waste to resources, more exchange of byproduct, energy, wastewater between industries. What does it mean? Environmental improvement happens significantly. More waste is utilized. Resource efficiency increases significantly. Dependence on virgin material reduce significantly. Dependence on the import of inputs coming from other places decrease significantly. Emissions associated with the importation of this virgin material from other places reduce significantly. Increase employment, increase recycling, increase the number of recyclers, increase the number of decomposer farms, those who are involved in converting one energy's waste to another in energy's resources. So these are some industrial benefits, as I mentioned to you. It will help generate less waste, reduce operational cost by avoiding the use of virgin materials, chemicals, water use, energy use, increase companies' income. So if you're reducing the operational cost, naturally the income will go up. Increase water efficiency by converting treated wastewater to usable water for industrial applications. Increase energy efficiency through cogeneration plant where waste heat is converted to electricity, avoiding the use of coal and natural gas, and water and energy security. So these are some of the things that are favorable features for Kwinana. This is an industrial park, and diversity of industries has got plenty of different types of industries like refineries, then fertilizer company, then mining industries. So they are contributing to each other in different ways, and they are capable of exchanging each other's waste with each other. So these are the places where industrial symbiosis are going on. In Australia, we have got two places. One is in Queensland, Gladstone, and one is in Kwinana. Kwinana, as I mentioned to you, and we feel proud of having this place in our next door, which is the iconic place of industrial symbiosis, and the whole world working on industrial ecology or industrial symbiosis know our place. And we used to have good number of visitors from Germany, Italy, who participated in our program and who took this Kwinana industrial area as a case study. So I'm going to discuss life cycle thinking, and because life cycle thinking is one of the approaches of significant approaches or main approaches for HEB of industrial ecology, and that is it reduces products, resources use, and emission to the environment because it helps find out the hotspot. It takes into account all stages of product life cycle. It doesn't take into account only one stage, and it helps find out which process, which chemical, which energy in which process is contributing most to the social impact, environmental impact, economic impact. Accordingly, technologies are chosen, and once the technologies have been applied, it can help address all these triple bottom line benefits to come up with sustainable solutions to improve social economic performance. As I mentioned to you, help restructure product supply chain. Restructure means that applying mitigation strategies depending on the type of triple bottom line hotspot, which can be identified using this life cycle assessment approach, taking all stages of product life cycle to avoid shifting problem from one life cycle stage to another, from one geographic location to another. It means that in life cycle assessment, we have to discuss the history, from where it is coming, and from where it is coming, what is the environmental performance in that area. So if the inputs are coming from Germany, we make sure that it is environmentally friendly, and so that we need to source inputs in a way that it is produced in an environmentally friendly manner. So when we will do the life cycle assessment of the product, so that it can the environmental or life cycle performance of the product can be enhanced by using inputs with less emission, less social impact, and less cost. So life cycle assessment, as you know that, so you are from life cycle assessment research group, it helps compare the environmental performance of the products doing the same job. So, and using the same system boundary, it can help identify where is the problem so that we can apply mitigation strategies. And once we have applied the mitigation strategy, we can turn existing product to a green product. And it is a decision-making tool, engineering decision-making tool, sustainability, and very powerful sustainability assessment tool. So I'm going to discuss one project that there are a good number of projects we have done. So this is related to industrial symbiosis. I want to give you the background, like as I mentioned to you before, that the gases in refinery, like in BP, in any refinery, oil refinery, when they convert crude oil to refined oil or purified oil, they remove SOx, NOx. So this is the main environmental problem with the refinery industries. So what happens that this gaseous emission, SOx, NOx, we can convert it to a feedstock for fertilizer industries. So in Kwinana industrial area, the refinery is located next to the fertilizer industry. So a symbiotic relationship can happen, and what happens that this so you need oxidant in order to convert this NOx to nitrogen peroxide. Then you need absorbent to convert it to nitrate, and this nitrate is a feedstock, and then you need to dry it. And once you have dried it, then you need to you can convert it to fertilizer. So there are different ways you can convert this NOx to NOx to nitrate, which is a feedstock for fertilizer production. Now we need to find out which is more environmentally friendly. They are doing the same job. What is the same job? They're producing the feedstock for fertilizer production. And if you look at here, there are 6 options, and 6 options can help you convert NOx to a feedstock. Now and they use different absorbent and oxidants. So there are 2 types of absorbents. There are 3 types of oxidants. So there are 6 pathways. We need to we have to determine which one can do the industrial symbiosis, which can convert the gaseous product generated from one industry to another industry's fertilizer in a environmentally friendly way. So we found that this 1.2, this the one option 1.2, that actually is the best option. Why it is the best option? Because the oxidant that is used here, production of oxidant used here, has less environmental impact. And in the case of 1.1, it uses ozone. The production of ozone is very energy intensive, carbon intensive. That's why there is no saving. But in the case of option 1.2, you get more saving. Now, option 1.2 and option 2.2, they use the same oxidant, but option 1.2 have more environmental saving than option 2.2. The reason is this: the absorbent for option 2.2 requires more drying. More drying means more heating. More heating means more energy. So that's why option 1.2, we have chosen option 1.2 as the pathway for industrial symbiosis. Remember, all this can do the same job, but option 1.2 can save more environmental, offer more environmental benefits than other options. And the way we have understood it, and we got this message via life cycle assessment. So life cycle assessment is a decision-making tool. It helps us find out which pathway, which reaction pathway to choose. That's the thing. Now I'm discussing another thing I have done with one of my colleagues long time ago in 2008. But in this case, we are considering the recovery of heat from industrial processes, and recovered heat can be used to generate electricity or thermal processes depending on the temperature by the neighboring industries. And how we have done it, I'm going to tell you. Now, this is a overall picture of waste heat generated in Kwinana industrial area. So this amount of energy is lost through waste, hot water, hot air, and flue gases. Now, instead of letting it go to the environment, we can capture it by different mechanisms. We can use heat exchanger, waste heat recovery boiler. We can use combined cycle, Kalina cycle, organic cycle. These are some of the heat recovery mechanisms that can potentially recover this heat and turn into a very useful useful resources, energy resources for the neighboring industries. Now, this is Kwinana industrial area, 8 kilometer long. It has got number of industries. So we have to cluster this industry. Why do we need to cluster this industry? We need to make sure that they can make friendship. Friendship means industrial symbiotic relationship. Industrial symbiotic relationship means that they can, one industry's heat waste heat can be useful resources by the neighboring industries. Different industries have different needs for different types of energy. So, and different industries produce different types of waste heat. So we have to select cluster industries in a way that the industries within the cluster can benefit from each other by exchanging waste heat with each other. That's the thing. Now, there are 7 clusters, 1, 2, 3, 4, 5, 7, 6, 7. So if you go here, you will find that this is the mechanism. Suppose we need to find out how much heat is lost. We need to find out that how much heat energy is required by this energy, by this industry, so that once we determine the amount of heat lost, we can recover energy. And we think that, yes, whether it can be used for electricity generation, then we need to think that whether this industry needs electricity. Yes, if this industry needs electricity, then we can marry these 2 industries, or we can make a symbiotic relationship between 2 industries so that this industry's waste heat can be useful resource for these industries. So that's the thing. Now, how do we do this? We need to do some calculation. So we are not supposed to expose the name of the industries because we signed a confidentiality agreement. So we have, instead of writing down the name of the industry, we are using A, B, C, D like this. So different industries, they're producing different amount of waste heat. We need heat exchanger. Heat exchanger has got certain efficiency so that we lost some amount of heat when we are recovering. Then we also lose some of the heat when we transfer heat via liquid air from one place to another place, or from one industry to another industry for application, etc. Now, as I mentioned to you, that there are 7 clusters, and so this I'm giving example for cluster 4, And in the case of cluster 4, we have chosen 15 options, and we had to pick up one which is best. So in terms of environmental aspect, what we found that this version, heat exchanger and combined cycle, it has got significant amount of environmental benefit. The reason is this, because it is replacing dirty coal and gas that is predominantly used in Western Australia to generate electricity. Now we need to find ways in order to make it economically viable. So that's why we have considered the use of carbon tax. We have considered the use of carbon tax. And if we're using carbon tax, if we're of $55 per ton, it is going to be economically viable. So we need to apply economic instrument in order to popularize, in order to make environmentally friendly technologies like this one, which has got huge environmental mitigation potential, an economically feasible option. So that is what happened here. Now, on this cluster, we have chosen this one. So likewise, we have chosen one option for each cluster. So and then we have worked out what is the total amount of greenhouse gas that can be mitigated by using best technological options, recovery options, energy technology options for both best case and worst case scenarios, because we were uncertain, because this project was not implemented that time. We based on literature values, so we had got high range, low range data on the basis of which we considered this range of mitigation. So I'm going to take another 5 minutes. The last example that I'm going to give you. Okay, now this material, this example that I'm bringing here, because this is very scary situation. Most of the material have already been extracted. We have small amount of material that remains under the earth surface. So if you're not recycling, remanufacturing, we will run out of all minerals, so that we cannot run the economy. So material intensity, that is intensity per product is very important. Estimate the amount of material to required to do the job. Like if it's a vacuum cleaner, it will take into account the amount of material used for plastic, metal, the cotton filter, etc., or electric cable plug, etc., in order to vacuum clean the house part time a day. So this, if we are able to reduce this MIPS, we will increase the resource efficiency, etc. This is a very useful tool. Now, the last presentation that is based on my doctoral students who completed PhD in 2019, and she got PhD on the basis of publication of 5 journal articles. And this is palm oil sustainability assessment, and it is a big issue at the moment. I've been recently interviewed by Singapore TV channel when Indonesia banned the use of palm oil, and what could be some of its sustainability implications. Now, I think this is not uncommon to you. You're familiar of this. So because of palm oil production, deforestation is happening, loss of biodiversity is happening, that is firing, slash and burn, all these things. It is causing health problem and etc. And also people are objecting because it is displacing people, it is affecting their agricultural land, it has got other implications. So, given this, we have developed a framework. Framework depends, any sustainability development framework that depends on the background, depends on the problem. And sustainability framework, the indicators we use, because when you develop a sustainability assessment framework, you need to have an indicators, social indicators, economic indicators, environmental indicators, and that vary from product to product. So what you will consider for the palm oil production in Indonesia may not be applicable for palm oil production in Malaysia or other places. So it depends, varies with regions, varies with products, varies with services. So indicator selection is a very important aspect, and we get experts involved to help us determine or discern these indicators. Now, if you look at this graph, you will find that these are the performance measures. Performance measures means that they are the smallest unit, and you need to integrate the performance measures to KPI, because each KPI or key performance measure has got a number of performance measures. Then each headline performance indicator consists of a number of KPIs or key performance indicators. So you need to integrate all these KPI to headline indicators. Then each headline indicator, each objective, each people bottom line objective, social, economic, environmental objective, each of these objective has got a number of HPIs or headline performance indicators. You need to integrate them to each bottom line. So if you this is the thing I already discussed with you. Now, if you look at here, this is the most important part. So these are the performance measures. Some of them are environmental, some of them are economic, some of them are social. And we got and my PhD student Chai-Ing Lim, Dr. Chai-Ing Lim, she actually interviewed 40 participants, balanced 10 from academia, 10 from industry, 10 from government bodies, 10 from researchers. So, and balance stakeholders. And by consulting with them, she was able to collect these indicators that are particularly important, relevant to sustainability assessment for palm oil production in Malaysia. So, and the different performance indicators have different weight. So she got experts to rank them on and use those ranking score to develop weight. So different performance indicators have different weight. If you look at this column, so weight, overall weight column, and you can see that once you have developed the weight, once you have selected this indicator, then you go to the field. Now you say goodbye to the expert. So goodbye, thank you very much for your time. Now you interact with the people, those who are working, those who are managing, those who are affected by this palm oil production. So you then ask this question, and it is a Likert scale, 5-point. If you see, this is a 5-point Likert, 5-point scale. So 5 is the best, 1 is the worst. So if somebody is giving you 3, there is a gap. Gap means 3 minus 5 is minus 2. So if you see here, in this case, the gap is minus 3, meaning that the stakeholder or the interviewer or the worker gave 2 scores. So 2 minus 5 is minus 3. So this is how you need to determine the gap. Gap means expectation, 5 expectation. So if it is 500% expectation fulfilled, so this is how these gaps were estimated. Once you have estimated the gap, then you can calculate the value of key performance indicators. How do you calculate the value of key performance indicators? Just look at here. So just for this one, this is known as air and water soil quality. This one, air and water soil quality. In this case, what you need to do, this is the summation of the product of weight and corresponding gap, meaning that this times this plus this times this plus this times this plus this times this plus equal to this value, which is this one. So this is how you need to calculate the values of KPI. This is how you are integrating the small unit performance measures to each KPI. So once you have calculated the KPI for economic, social, and environmental aspect, what you need to do, you need to average the KPIs for each headline indicators. So this is the headline indicators, and this is the KPIs. These are the KPIs for these headline indicators, meaning that you need to average them. Once you have averaged them, this is the value. So the same thing you need to do for economy and social. Then you need to average the HPIs under each people bottom line objective. This is economic, this is environmental, this is economic, this is social. So that once you have averaged this, so you get the value. So ladies and gentlemen, you will see that there is negative everywhere. Negative means that it is less than 5. Less than 5 means expectation is not met, means more social improvement needed, more economic improvement needed, more environmental improvement needed. Then you can, if you average this, triple bottom line values of these 3 indicators, you get the total sustainability value. This is the sustainability gap, and this is the gap for environmental, this is the gap for economy, this is the gap for social. If you average them, you get the overall sustainability gap. So overall sustainability gap is, say, this is 1 minus 5.3. So we need to find out where is the hot spot, because life cycle assessment help us where the improvement is needed. In that case, environment is the most problematic area compared to economic and social. So we focused on this. So we found that emission associated with palm oil effluent is very significant. We considered the use of biogas plants so that methane, instead of discharge into the atmosphere, it can be converted to electricity energy, and in the digested slurry in the biogas plant can be used as a fertilizer. So once you have incorporated that improvement strategy, you can further improve the environmental performance. This is the environmental performance, so you can improve further the environmental performance. So it is reduced to this amount. So the total. So this is how we can use sustainability assessment framework to find out the hot spots, so that overall, so that mitigation strategies can be applied and overall sustainability performance or can be enhanced, etc. So these are some of my conclusions. So energy symbiosis is an effective strategy to reduce environmental impacts. There are 4 types of symbiotic relationship I mentioned that can help enhance symbiotic relationship, reduce waste, reduce energy, reduce water, and conserve more resources for our future generation. The concept of eco-industrial park can be developed in planning stage. So before we need to make sure which industries we are going to plan in a certain industrial area, so that they will be capable of exchanging each other's waste. So that's important. Otherwise, if we don't do this, so we will have industries, waste will be generated, but that waste may not necessarily be useful for the neighboring industries. So there are factors to be considered for successful industrial symbiosis projects. And I think management is very important, coordination is important, and collaboration is very important, so that there needs to be a contractual agreement between industries, so that one industry accepts the waste from another industry for a certain period of time. So life cycle assessment is a tool for materialize the concept of life cycle thinking. Life cycle assessment tool, it assists in the selection of green products and identifies opportunities for environmental improvement. It assists in the selection of cost-effective environmental mitigation strategies so that once we have determined the hotspot or problematic area, we come up with different options. So we need to select the option that can improve the environmental performance without entailing the excessive cost. So it helps in the development of strategies of natural resource conservation. Of course, if you save energy, if you save material, if you reduce waste, you can reduce 2S's, source and sink, and this is how you can leave a better world for your future generation. Acts as a decision-making tool, which option to choose, as I mentioned to you in my in that application, like symbiotic relationship happening between fertilizer industry and the refinery. So one industry's gaseous emission converted to feedstock for fertilizer production. There are 6 options. So life cycle assessment will enable you to choose which one to choose. That's the thing. So and results in enhanced material efficiency, waste management, supporting the principles of both circular economy, so that if you're reducing 2S's, we can sink and source. It can help us convert a linear system to a circular system or circular economy and conserve more resources for the future generation. So thank you very much for listening to my presentation, and I open the floor for questions. Thank you very much indeed.
Thank you very much, Prof. Biswas, for the very completely presentation and very interesting presentation about industrial ecology and sustainability assessment. What we can get from this presentation, we can know that how life cycle thinking improve its social and socio-economic performance, and then reduce product resource use and emission to environment, and help constructive help restructure supply chain of product. And also we can know from this presentation, we can know about industrial symbiosis, and also Prof. Biswas has been present about his study about gaseous synergy application of industrial symbiosis, and also about identify and evaluate economic, technical, and environment feasibility in the Kwinana industrial area, and also about sustainable assessment in palm oil industry. Now from the participant, you can ask or discussion to Prof. Biswas. You can ask indirect to ask Prof. Biswas, or also to the chat. But I think we can see in the chat, Prof. Biswas.
Yeah. Okay.
We have some question.
Okay, I'm going to the chat. I'm going to the chat box. Okay.
Okay.
Let's see where the question starts from. Let me check. Question 1. Okay, how's the standard of sustainability assessment in industry in Australia? Is this any industrial sustainability report? Yeah, yes, I think sustainability is an important component of any heavy industries. Like Australia is responsible for, is mainly involved in exporting minerals and ores, gas and livestock products, and they need to be certified by ISO 14,000 guideline. And ISO 14,000 guidelines means that they need to achieve certain environmental target, and they need to be certified by ISO 14,000, without which they cannot export their product to other countries, so that for business purposes, they make sure that they have got this environmental management plan. They're reducing emission. Of course, every industry, they have got a heavy industry, they have got a sustainability report. And this sustainability report, if you look at here for BHP, Rio Tinto, Alcoa, or any industries in Australia, they have it is a compulsory, and they need to make it public. And there are 2 guidelines they can follow, like GRI, Global Resource Initiative, or World Business Council for Sustainable Development. Australia may have their own sustainability guideline. So yes, industries are required to have this sustainability report done. Yep.
Okay.
So then another from Professor Yun Fatima, that I'm listening to your good presentation. This is just a comment. Then I have got a question. Some CPO industries using microalgae to handle foam waste. Okay. And what do you think about this? I think microalgae is I think you can, that's a good approach, like using, if you can produce microalgae, you can convert microalgae to biodiesel, and that biodiesel, because if you're producing producing this biodiesel from algae, you can be actually, in many instances, you can be carbon neutral. The carbon neutral means that it is negative carbon dioxide, which is good. Why? Because when you produce biodiesel from canola seeds, it is not carbon neutral, because you need to use fertilizer, pesticides, farm machinery operation. All these things are actually adding carbon dioxide. But if you're using microalgae, I think that's a good strategy, because some mining industries, they're using their effluent to grow microalgae, or they're growing and I think that can help biodiesel production. I think this is one of the use. I think this depends on the climate. This depends on the situation, etc. Now, another question. Yes.
Yeah. Previous Prof was from Agusta Samudra Putra from University of Ulsan. Nice to meet you, Prof was. Now I'm working with Ulsan IEP South Korea. I think the implementation of IS or EIP is characteristic based on the country. You already explained about the benefit of EIP. However, could you explain about the specific implementation strategy of Australian EIP? I am interested about the IS development in Kwinana Industrial Park. Yeah.
Oh, okay. I think Kwinana Industrial Park, one thing that this was not actually developed in a way for when it was, I think it was not developed for industrial symbiosis, but incidentally what happened that it was found that one industry's waste can easily be used by another industry. Clear? So in the case of eco-industrial park, one of the main things that needs to be done, that we need to make sure before developing that park, we have to make sure that the industries that will be developed in that park are capable of exchanging each other's waste. But I think in Kwinana, it was not developed from that perspective. But incidentally or luckily, it was found that one industry's waste can potentially be used by another industry. But I think the concept of EIP is very important because it can, if we know the industries in advance before the development of an industrial, eco-industrial park, I think that can further increase resource efficiency in more economically and environmentally feasible manner. I don't know if it answers my answer, the
Thank you.
professor's
So,
question. Yeah.
Yeah. Thank you. Actually, nice to meet you.
Okay.
Yeah.
Oh, nice to meet you.
Yeah, nice to meet you. Yeah. So, yeah, my intention is about the implementation strategy. As you know, that like in Japan, they use the eco-town approach, but
Yep.
I would like to know that whether in Australia is which approach they use from the national level until the industrial level. So yeah,
I think it happens little bit automatically because it was not planned system. Okay, EIP, what is needed that you have to plan what could be some industries that can potentially exchange. But in that case, if you're planning, that symbiotic relationship will be more useful, more beneficial environmentally and economically. That's the thing. Yeah.
Yeah, like happen in China, they use from the national level, as you know. Yeah. So, but maybe your approach is same as the Kalundborg, as you know.
Oh, Kalundborg was the same thing because Kalundborg, they did not plan even, but they found that there is an opportunity, opportunity for exchange. That's the thing.
Yeah. Until though is Kalundborg is the benchmark. Yeah. Thank you very much for your answers. Maybe we can
thanks for your good question. Thank you very much. Much appreciated. Yeah. So there is another question. I don't know if I have answered the question correctly to Mr. Ira Noor. Sorry, Dr. Ira Noor Hayati. I am not sure.
Yes.
So, okay, good. Now, the next question is for social life cycle assessment and economic life cycle assessment, any particular application database that are used, and sometimes like LCA. That's a good question. That gives me an opportunity for further clarification. Now, yes, when you do, we actually now call environmental life cycle assessment instead of life cycle assessment. So life cycle assessment consists of 3 tools: environmental life cycle assessment that determines environmental indicators using the same system boundary, using the same number of stages. You can do social life cycle assessment, you can do life cycle costing. So in the case of environmental life cycle assessment, you are taking into account the chemicals, energy, kilowatt hour, megajoule, kilogram, tons, etc. So you're converting them to environmental impact. In the case of life cycle cost, you use the same inputs, but you convert them to dollar. Okay, you do the economic analysis. But in the case of social life cycle assessment, now what you do, instead of your impacts, in the case of environmental life cycle assessment, the impacts are global warming, acidification, photochemical smoke, all these things. But in the case of social life cycle assessment, your social impacts are human rights, working condition, cultural heritage, all these things. So now, in the case of environmental life cycle assessment, you have got, as I mentioned to you, that chemicals as an inventory. But in the case of social life cycle assessment, you, based on people's perception, their value judgment, their expectation, so fair, unfair, happy, unhappy, advantage, disadvantage, satisfaction, not satisfaction, agree, disagree. So you have to, what happened that these are called inventory, and you need to convert, and you need to have a Likert scale. I showed you Likert scale when I was present, giving the case study presentation of palm oil, that you need to have a scale. 5 is the highest, 1 is the lowest, so if the expectation is met, there is no gap, 0. Okay, 5 minus 5 is 0. If it is 3, then the gap is minus 2. Okay, so now why I am telling this, that this database is not a big task. it is you once you interview people, you get data now. But I think these indicators vary from country to country. What if for the same product, the indicators that I will use in Indonesia, I will not be able to use those indicators in Australia because socioeconomic condition, consumption, energy mix, they're different to each other. Okay. Now, when you're considering the database, mostly it is important for environmental life cycle assessment because we deal with emission factors, and emission factors plays a crucial role in environmental life cycle assessment because this emission factor means that you have to know the processes, you have to know the energy consumptions, you need to know the local data, so it is a time-consuming task. But in the case of social life cycle assessment, this is not an issue because you're talking to people. Once the people are happy to talk to you and give you their feedback, you can convert their qualitative judgment to quantitative values. That's the thing. Not sure if I have answered your question. Is it okay? Or some further correct? Oh, thank you very much. Oh, sama-sama.
Yeah, thank you, Prof. Wismas, for the answer for Dr. Ira. Maybe any participant, if you have a question. Oh yes, there is a question from Bu Amita in the chat box.
Okay.
Yeah,
I would like to. Yeah, please. Yeah.
I would like to know how we could assess sustainability of an industrial cluster, including the impact of to the surrounding community, and is it should be conducted when the management of the EIP?
Okay, I'd like to. Yeah, good. Sustainability of including the impact of suffering. Oh, that's good. Good question. I think good. I think, of course, yes, I think if we are able to reduce this way, I think surrounding communities' involvement is very important because they experience pollution, they experience the degradation of natural resources. So I think they are consulted. They are consulted, and when some symbiosis is done, I think symbiosis means converting waste to resources. Like I mentioned to you, that gaseous emission that can be converted to useful feedstock for the fertilizer industry. I think if all this waste and emissions are converted to resources, and I think it will improve the situation of the surrounding community. I think to some extent, surrounding community, they take part in industrial symbiosis process. I think in Australia, they engage them. And we have Kwinana Industrial Council. Kwinana Industrial Council is the matchmaker because it helps liaise industries with each other. So when they do meeting with the industries or different, they also engage local community so that that takes into account feedback from the community. Yeah, I'm not sure if I have answered your question correctly, or I'm happy to clarify further.
Bu Amita, apakah sudah cukup jawabannya? I think it's
yeah.
Okay, Bu Amita. Yeah, silakan Bu.
Yeah. Well, I think it's okay because in Indonesia we have many industrial clusters that consider also the impact the environment, the community, the surrounding community, and usually the cluster, the EIP, give the community with the CSR funding, something like for building schools or maybe for the religion place like mosque or and everything. And I mean, the facilities for the community. But in other cases, cluster provide the in medicine, traditional medicine. So the industry, the cluster industry, provide help for the community to grow the plant or that the industry need as a source of the medicine, traditional medicine. So I think this is a good example. So that's why I will ask you if there is a sustainability assessment for the industry, not the industry itself, because in the cluster industry, it consists of many industries. So the cluster itself should be managed, and how they, to assess the sustainability of the cluster itself. I think it will be different with how we manage or we assess the industrial entity. So the first thing is that how we assess the sustainability of the cluster, and also the should the management of the cluster doing that, including the impact of the environmental sustainable, the surrounding community. That's what I mean. So should be in short, should be the management doing the sustainability assessment.
I think
who is responsible to do that?
Oh, yes, of course, the management is responsible for doing this. And you have actually shared very nice experience, what is happening in Indonesia, that there are cluster of industries and you have funding for corporate social responsibility that allow industries to take care of the surrounding communities and environment and enhances their symbiotic activities, reducing waste emission. I think management is responsible, because when you do any sustainability report, you need to have top management involved, whether it is sustainability report or environmental management system. Without the involvement of chief executive officer, you cannot have an environmental management system or sustainability reporting done. And you need to engage all people from blue collar worker to chief executive officer, and all are involved in the development of sustainability report, because you need to make it public and you need to declare the roles and the actions that are taken in order to achieve social performance, economic performance, and environmental performance. So I think when there is a cluster, you need to have an organization that helps industries to liaise with each other. Like in our Kwinana industrial area, we have got Kwinana Industrial Council. That Kwinana Industrial Council is responsible for this Kwinana industrial area, where we have got a number of industries, and they are responsible for developing a sustainability report showing that how the collaboration between industries helping reducing this environmental impact, etc.
Okay, thank you. So it's done in Australia, about the council providing the sustainability report. It should be.
Yeah. Because you cannot expect each industry has got a sustainability report. Because they are required to have. But in the case of when it comes to symbiosis, because then the council take the proactive action. Yeah.
Okay. Thank you. Thank you very much, Prof.
You're most welcome. Yeah.
Oke, terima kasih Bu Amita. Thank you Prof.
Sama-sama.
Ya, any question from the other participant?
Direct question, is that possible, Pak
Yes.
Mas Hermawan?
Ya, boleh langsung saja bertanya. Kalau ada yang tidak bisa bahasa Indonesia juga nggak apa-apa. Nanti saya bantu.
Mas Hermawan. Thank you, Prof. Biswas. I just wondering, we know that in Western Australia, you have a water scarcity very, very harsh. I mean, 30% of the water supply in Western Australia is coming from the desalination water system. Is I'm correct, right?
I think it may be more than this at the moment because we have got 2 desalination plants. Okay, the reason is this: until 2005, we used to get water from dam, but because of climate change, water level went down and not enough water. But Western Australia have got 2 things: money and seawater, so that they're converting seawater to drinking water. And at the moment, this is 100% run by renewable energy technologies. Wind power and solar power, they are used for running the reverse osmosis system, which is very energy intensive. And I conducted the life cycle assessment of desalination plant in 2009. And they actually base their plan on the basis of my research, because I found that if they're using renewable energy, because Western Australia is blessed with renewable resources, coastal area, you will find lots of wind, and that wind resource can potentially be converted to electricity to run this reverse osmosis system, to convert this salt water to desalinated water. So we don't have much surface water and much, but I think we have got plenty of ocean water next to us, and we have got plenty of wind. So we are using these resources to produce water to meet the significant demand of our water consumption.
How the Western Australian government deal with the sustainability assessment on the water scarcity? I mean, how you manage the water footprint in each single area, and then how you categorize and make the index?
Okay, actually, honestly, we haven't experienced any scarcity because we have got alternative options. So at the moment, we are considering the use of groundwater reclamation plant. Groundwater reclamation plant means that the wastewater, after you have treated the wastewater, you are not sending it to the sea. What you are doing, you are injecting it to underground aquifer, meaning that before you inject the treated water to underground aquifer, you do further treatment or advanced treatment using reverse osmosis system. Means that you have got treated water, it is not going to the sea. What is happening? It is going through the reverse osmosis system. Then it is injected into aquifer. Now that water will be drunk, I think, in 10, 20 years, because it will avoid the stigma that people will not think they're drinking somebody's wastewater. So that one is happening at the moment. One of my students have done we have published a paper on groundwater recycling scheme. I think that time it was a pilot project. Now it is going to be a big project. So I think what happens that we have got technology, we have got financial resources, we have got technologies, so that I think we are coping with the changes to address water challenges. That's the thing.
Thank you, Prof.
Ya, terima kasih Pak Nuk. Ini ada Prof. Biswas. There are question from Ibu Tria. The question is about life cycle assessment. If we have life cycle assessment for agro industry, and this life cycle assessment for production of 1 ton of organic fertilizers in one cycle, how much minimum of maybe using secondary data or database for the assessor to define that the industry has been done life cycle assessment.
Okay, good.
Is there
So,
any minimum? Yeah.
Okay. I think, thank you very much for your question. I think it is the life cycle assessment of organic fertilizer. Now, when we do any life cycle assessment, it is not possible to get 100% field data. The reason it's not possible. So, and life cycle assessment is a data hungry tool. So now it is important to get as much as local data. So otherwise we use surrogate data. Surrogate data means that if you don't know the chemical of some process, so if this data is not available, you can use the data from other similar process. Now, I think more you get local data, more it enhances the quality of your LCA. But sometimes time is a constraint, resource is a constraint, and it doesn't happen. So what is the best thing when you do LCA? It is always good to list down your limitations. Confession is the good thing to do, that yes, this is what we have, this is what we don't have, this is what we have assumed. That is one thing. Number two, what you can do that to do some sensitivity analysis, which is we use CIMAPRO LCA software, and we use that is Monte Carlo simulation, and that gives us some correlation value. And Monte Carlo simulation, it runs for 1,000 times iterative process that shows that how the input data that you have used to do, how the quality of input, what is that is, how does it affect the ultimate result? Means that it determines the quality of input data used, so that if it is 90%, 80%, that's good. So even if you get 75%, it is still acceptable. So it is good to have some sensitivity analysis done. So that how does the value, input value that you have used affect the quality of result? That we do some statistical analysis that you can do. Yeah. Does it answer the question?
Apakah sudah jelas, Bu Tria? Yeah, I think it's clear. Yeah, I think there is no any question. Oh ya, there is one question.
Ya, Pak.
Okay, ya.
Ya, Pak Hen, ada di chat, izin. Ada softwarenya nggak, Pak?
Oh ya,
Bisa dipakai.
oh ya. Sebenarnya tadi sudah dijawab, Bu, dengan CIMAPRO tadi, Bu. Salah satunya ya, Bu. Salah satunya.
CIMAPRO ya, Pak ya, izin ya.
Salah satunya, ya salah satunya.
Salah satunya.
Bisa dengan OpenLCA juga bisa. Gitu.
Oke, ya terima kasih.
Ya, Bu. One question from Ibu Yun Arifatul Fatima.
Okay, Professor Yun Arifatul Fatima. Industrial symbiosis is one strategy supporting development of a circular economy. Very good. I think it needs a form of collaborative supply chain management. Yes, agree with you, to make the industry more sustainable and achieve collective benefits. Good. Yes, collective benefits, because this is collectively done by a group of industries within a cluster to achieve more economic benefit by reducing their operational cost, reducing the cost on waste management, reducing the cost on virgin materials, etc. My question is, what are the big challenges and innovation to applying industrial symbiosis successfully, and what can we learn from Australian cases that can be applied in Indonesia to achieve more sustainable circular economy? Thanks for your useful and very valuable question. Now, what happens that I think there are some risks associated with industrial symbiosis, because what happens that in the case of two industry, they come up with contractual agreement for 10 years or 15 years that yes, you have to use my byproduct, and another industry will say that yes, I can use your byproduct. So one industry's byproduct is going to be the resources for the neighboring industry. But in some cases, what happens that the industry which is using the byproduct from another industry, they are fixed, means they cannot change, means that if there is a market change, they can move to another. Because of change in market, they cannot move to another product, another production processes. Yeah, got my point. So I think that is a big challenge. And also, you are not sure that the production of byproduct may be reduced because the industry may shut down. I think so. I think these are some of the risks. But in Western Australia, still this symbiotic relationship is going quite well. That's the thing. Yeah.
Ya, silakan Bu Yun. Masih ada respon.
Yeah, Professor. Thank you very much. I think that is enough. It's nice to see you, Professor.
Yep.
It's okay.
Good. Thanks for joining the presentation. Yeah.
Thank you. Any one last question, maybe, before we close this webinar?
Reaction.
Bu Amita mau tanya lagi, Bu?
Iya.
Ya, silakan.
Boleh ya, sedikit ya.
Okay.
Professor Biswas, may I know about the waste exchange in the industrial cluster in your country? The waste exchange. So waste from one industry to be the source for the other industry in your country, in Australia.
Waste exchange, a solid product, like I mentioned, that gypsum that is produced in fertilizer industry, that can be used for soil amendment purposes in the residue area of alumina refinery, because alumina refinery, they produce bauxite residue, and the bauxite residue area is very alkaline. So that if we are using gypsum for soil amendment purposes, that is good. So number two is lime clean dust. As I mentioned to you, it can be used in pig iron production. So Kwinana industrial areas has got some iron industries, or the rate. Another thing, that the carbon dioxide that is produced from fertilizer industry can help neutralize, because bauxite residue is alkaline. So we can use carbon dioxide to neutralize this bauxite residue to produce red sand. And that red sand we can use in road construction material. And we proved that the use of red sand is structurally sound and can replace limestone and sand for construction materials. So I think this most of the byproducts that is coming out from industrial processes, these are their inorganic byproducts, and they have got good cementitious properties like slag, fly ash, and GGBS. granular dust furnace slag, we can and this has been used as construction materials. Also, this one industry's wastewater is treated and used by the neighboring industries. That is happening in Kwinana industrial area. Also, the cogeneration plant that I mentioned to you, that it accepts because a couple of industries, they're producing huge amount of waste heat, and heat exchanger used to recover this waste heat to run the cogeneration plant. Cogeneration plant is producing electricity and giving this electricity to those plants which are contributing to this waste heat to that cogeneration plant, so that industries and cogeneration plant, they're mutually benefited from each other.
Yeah. Moreover, I'd like to add some questions. I mean, just a little. Are those industries located in an IEP?
No, they're actually they're not actually. When these industries was constructed, there was no environmental there was no plan for eco-industrial park, but it happened incidentally, very luckily. Okay, so but these industries are closely located, means that I think maybe between 200, 300 meters apart from each other. Yeah, apart from, and there are very big industries, very big industries, like you see refinery industries, cement industries, that you will find. I think iron ore industries. These are big industries located next to each other.
Yeah, because usually in Indonesia, EIP is a close big area, consists of industries. So it is, I think, difficult to practice the waste exchange between because maybe they are not used. I mean, not rechangeable materials that needed by the industry. So it would be difficult, I think. But except like the industry that you said, only different. I mean, only 200, 300 meters away, so it would be easier to replace or to chase the waste. Okay, thank you very much.
I think it's important, but sometimes I think it may happen that you can use truck to, if it is 1 kilometer, it's still okay. It is happening somewhere else. Yeah.
Thank you.
Okay, thank you, Bu Amita. Thank you, Prof. Wiswas. I think the time is now to 12 o'clock. I think this webinar will be closed from now. And I think from the participant, if there are any question, you can contact by email or some communication communication direct to Prof. Wiswas. And then for this webinar, we can get that we have many discussion and many questions from the participant. I hope this webinar will have any improve knowledge for everyone to know about industrial ecology and sustainability assessment. From me, I thank you. Thank you for Prof. Wiswas. You can present very completely interesting to this webinar. And then I return to MC Bu Yaumil. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you very much for these opportunities. Thank you. Thank you very much. Bye-bye. Thank you, everybody.
Wait, Prof. Wiswas. Okay. Bu Yaumil. Oke.
Baik, terima kasih. Baik, terima kasih Bapak Hermawan yang telah memandu jalannya webinar pada hari ini dengan luar biasa. We would like to thank you to Professor Wiswas for outstanding presentation. For express our appreciation, we will give you a certificate as a speaker, Professor Biswas. We will send it to you. Thank you very much for your time. Here the certificate, Professor, we will send it to you.
Thank you very much. Thank you very much. Terima kasih. Thank you very much.
You're welcome. Hope to see you soon. Baiklah,
And that's a great opportunity. That's a great opportunity, and thank you very much. Yep.
You're welcome, Professor. Baiklah, dengan berakhirnya acara utama, maka berakhirlah juga acara webinar kita hari ini. Kami harap webinar ini dapat memberikan informasi dan tambahan pengetahuan bagi kita semua. Kami mohon maaf apabila terdapat kesalahan dan kekurangan selama berlangsungnya acara. Terima kasih kepada para hadirin atas partisipasinya pada hari ini. Sampai bertemu pada webinar selanjutnya. Wabillahi taufik wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Prof. Biswas. See you in December.
Thank you, Professor.
Assalamualaikum. Thank you, Professor Fatima. Thank
Yeah.
you, Hasnin. Thank you, Nugroho. Thank you, Professor Nugroho. Thank you very much, everybody.
Terima kasih.
Terima kasih Bapak Ibu semua.
Sama-sama. Thank you very much. Thank you. Thank you very much. Thank you very much. Thank you. Thank you very much. Good.